Okay guys, welcome back. So last time I was showing you how to enable snapshot standby for your database. So what I was doing wrong is, if you look at the two windows that I have open, right? So now it shows that restore point only is divided for flashback is export to restore point only. So in the instruction you should see that that basically your flashback has to be turned off before you can enable before this setting will be set will be configured. So what I had to do is I had to shut down my database. Shut down database, start up in my mode. I had the database flashback off. So let me actually paste that in here somewhere. Start up in my mode. Turn off flashback. Flashback setting. Use command. Run command. Author database flashback off. There you go. So after you turn off flashback, then you can then convert your database. So I ran the auto database convert to snapshot standby, restore point only, and database. And again, so after I open the database, so I ran the select flashback on. And also, if you also run the if you query the database row, so if you run select database underscore row from the database, then now the database row is set to snapshot standby. Okay, so what I'll do next is I'm going to do some testing. So I'm gonna create a table. Let me see. I think this might be. So create table. Yeah. So I should be on the standby database. So let's just make sure that's clear. So create table test one. Select star from HR. So copy that. Come here. Paste it. There you go. Table's been created. So now I'm going to confirm that what I have in my the folder that I have in my test one table. So run select star from test one. Great. So I'm going to return my snapshot standby database to a physical standby database role. So return change the snapshot standby database back to physical standby database. Physical standby mode setting. Physical standby role setting. Okay, so I'm going to shut down my database. Remember, I just created a table test one, right? So I'm gonna shut down my database, start up in my mode, return it to physical standby, and see if I still have my same data set, which you and I can just basically looking at it right now. So I'm gonna shut down my database, shut immediate, shut it down, and then I'm gonna start from out mode. Okay, it's been shut down, so start up in mount mode. To start up mount mode, when database is in mount mode, I'm going to convert it to physical standby with auto database convert to physical standby. So auto database convert to physical standby. And after I convert, I'm going to shut it down again. Start up in no mount mode and then mount it as a standby database. So basically, this is what I just told you. With a snapshot standby, you would place a database snapshot standby mode to basically just test out and do some evaluations on basically if you're doing application and whatnot. So yes, it's not a it's very usable, but you gotta it's really about the situation, circumstance that you're in, that that yeah, it's really about it, what circumstance you're in, and don't just think you can do whatever. Just be aware of what the circumstance may be. So what I'll do next is I'm gonna shut down the data. Okay, so from my standby, I'm gonna shut down database again. So run shut immediate, and then I'm gonna start up in no mount mode. Start up no mount. And then after I've started database in no mount mode, I'm gonna mount it to the standby database. So then run auto database mount standby database. And then after I've mounted the database, I'm gonna place it in manage recovery mode. So auto database recovery manage standby disconnection session. Or you can just omit the from session part. It's the same query. It's the same command. And then after that, I'm going to check. I want to confirm what my flashback mode setting is, and it should be set to no. So apparently it's already been set. Great. So no. So when you see this message, right, the incompatible media recovery is already active. Just know that the database is already in man recovery mode. That's what it means. That's what the message, basically, is pointing to. So I just confirmed that the flashback is set to now, and I'm gonna run the select star from test one again to see if I have if I haven't created my test table. Oh yeah, I have to open it. To database open. Copy that. Paste it. There you go. And I'm gonna run that select statement again. Table of view does not exist, but what we just want to is we actually create a test table, right? The test one table. So what this means is, as I just told you, that you only the data that's in that snapshot standby database is not available when you send the database back to physical standby mode. So yes, changes made to the snapshot standby database a rollback when your database are returned to physical standby database mode. Let me make sure I have that correctly down here. Okay, there you go. So what I'll do next is I'm going to close this and go to the next part of the tutorial. So for data guard, when you for your primary and standby database, you have these two parameter settings, right? The fal underscore server and the fal underscore client. These are settings. So fal stands for fetch archive log, and basically what you're doing is you're assigning service names to these databases. So in terms of how to configure what values to assign to these parameters, so if you're on a primary on a standby database, so it's again, so doing some research, found some posts about the setting these two parameters about being advised to set these parameters only on your standby database. I'm not sure how if you know if it's going to be plus if you're going to affect your configuration negatively if you have it also set on your primary database. But basically on the standby database, you assign the value of the remote database to the fal server, and then you assign the value of the local database to the fal client. So if I go into my init file for my standby database, I should have fal underscore client set to my standby database. So open up this file. So there you go. So fal client is set to the standby database, fal server is set to the remote database, which is the primary database. So, and again, just always be reminded of that. Let me minimize this. So basically, this is actually these two parameters are actually helpful and actually basically they're helpful in helping in resolving log file gaps. Log file gaps occur when data is not being transferred adequately, right? So a possible error that you might come across is the 0016401 when you have missing archive log files that were not safely transferred. Missing that were not safely transferred to the standby databases. And again, you might have different reasons, and then it might be down or the standby database is shut down. And mass protection mode can prevent log file gaps from occurring. So basically, you would have to change the protection mode setting. to maximum protection mode. And basically, what max protection mode does is it actually restricts DB users from committing new SQL transactions on the primary databases if they're not being applied successfully to standby databases. So basically, the screen is the window is gonna the client is going to stall. The SQL Plus client is going to stall, and basically that means that standby the redo data was not applied successfully to the standby database. And this is one of the functionalities of the maximum protection mode setting. And if and again so yeah so and again so if the redo log is not applied to the standby database and you have maximum protection mode enabled, you're gonna have the client is gonna stall, but eventually the database is gonna be shut down. It's gonna be a full shutdown for the primary database. So this is this is one of the ways to ensure that all of the redo data is being transferred and applied to standby databases from primary databases. So okay. And then in terms of log file guide resolution, that's actually this is actually a procedure. So and again, so basically this is okay. So procedure. So what it entails is basically what you're doing is you are making sure that that no missing archive log files that there are no missing archive log files from a that missing that archive log files that do not go missing as they're being part of being transferred to the standby databases. And an explanation of the log file gap resolution. And again, so this is a process actually. The log writer on the primary database is actually is going to continue to write the online redo logs, and the archive process will continue to archive online redo logs that have failed with transaction data. So everything is going to be going on as usual internally for the primary database. And then eventually, when the log file gap is resolved, that's when the data is going to be transferred. This is what log file gap resolution is. In terms of processes, you have the archiver process. Remember I told you I've went over a little bit earlier about you have the log writer and you have an archiver process that you can configure as the driver for the process responsible for transferring redo data from the primary to the standby database. So the archiver process basically pings the standby databases to confirm to see if they are shut down. So okay, let me actually just just explain what it really does. So ping standby databases when they are shut down to check if communication with the primary has established. So this is, and again, this what you're doing is you're trying to resolve the log file gap resolution, right? And you're dealing with missing we're missing archive redo log files and the standby databases that's down. And then what it does is the archive process. What it does is it monitors the control files for standby databases to find the last archive redo log file that was applied successfully. So first it's going to ping the standby, then it's going to mount its control file to get it the exact file archive read log file that was applied to it. And what it's going to do is it's going to then create additional archiver processes to find and apply any missing archive log files to the standby database. So these are the operations that are performed by the archiver process. And then you have the log writer process. The log writer process actually writes committed transactions to online redo log files on primary databases. And again, what you can also do is you can also just have this be the process that's responsible for transfers of video data by you're setting up the log archive desk 2 and the service setting. You can have a log writer perform this the basically what the archive is doing. You can also configure the log writer to do the same thing. And then you also have the RFS process, which is the remote file server process. Basically, it runs on the standby database. What it does is it oversees the communication between primary and standby database. And again, so this is dealing with the log transport service. It can also receive video data from archive or log writer processes from primary databases. And what we do is it's going to then write the video data that it has received to file systems that are on the standby database. That's what the remote file server does. Basically, it runs on the standby, receives video data, and basically applies that video data to the file system on the standby database. That's the remote file server process. And then you have the LNS process, the log write network server process. It's responsible for establishing connection to the standby databases. And again, so the LNS, yeah. And what it also does is it transfers archive video logs received from primary databases over to standby databases. So basically, this is a process that's and so I just gave away the definition, but when you have archive video log files that are on the primary database, this process is going to then ship those archive video log files to the standby database, which can then which would then eventually apply the video data to bring that standby database to a consistent state. And then you have the MRP process, which is the managed recovery process. Basically, it maintains, and then what it does is it also applies the video data that's been transferred, the transfer video data to the standby databases. So this is, and again, that's remember I keep going back and forth between taking my standby databases out of managed recovery mode or placing it in managed recovery mode. This is what managed recovery mode does. Basically, it's just applying the video data to the standby databases. Video data it has taken from the transferred archive video log files. And then you have data guard services. This is something that I sort of covered early on. You have log transport services. Basically controls transfers of video data to standby databases. This is, if you remember the setting that I showed you on the on my book configuration. I closed that window. But anyways, yeah. So it transfers the video data to the standby databases, but also the settings actually transport on. So I don't know if I'll be able to pull it up, but let's just try it. So DGMGLL. Okay, let's do a show configuration. Yeah, it's not gonna do it. So let's actually do a show database. There you go. So transport on intended state. These things I'm gonna have to fix them later on. It's not a big deal. So for because I just queried this primary database, I have a transport on, and if I was to query my standby database, I would have my reply on. There you go. Apply on. For some reason, I do have successful here. So also this is what you're looking for. You want to have a database that is such a success for your after you query your databases. your standby databases. So and again, so you have log apply services responsible for applying video data, archive video log files to standby databases. And then and also in terms of the specifics for the archive video log files, so video data, the archive video log files that are basically shipped from primary database, they have to be completely filled before the log apply services is going to start applying that video data to the standby database. This is the default setting. So pretty much you have a filled archive log file coming from that's being transferred by log transport services on the primary database and then transferred to the standby database. And then you have the log apply services that's checking to confirm that the archive log file is completely filled. And then what it's going to do is it's going to apply that video data to the standby database. So going to the next step, next screen. So just more explanation on the log transport services. So you have the primary database here, right? So primary database goes to the invites to the archive video logs, and then eventually this data is going to be the data in the archive video logs and these other same files is going to be sent to the standby database, but it's going to be not sent but applied to the standby database. So the log transport services goes to the archive logs, gets the read data in the archive log files, and then eventually ships that data to the and again not ships that data not completely, but it's kind of, again, the diagram is just there, but it's not yeah. So ships to the standby database, and then eventually that is applied to the standby database by log file services. And you have here at the top, you also have basically everything I just explained. So you have a primary database, you have a log writer that's writing to the online video log files, and then eventually there's the archive process. After you've committed your data using the commit command, you're creating archive video log files, and again, so your database in archive log mode. When you switch your log files, when you switch your archive log files, archive process is then responsible for going to the archive logs, and then eventually the archive logs are going to be shipped to the standby database. So this is what's going on internally. This is more of a this is a so for this diagram, I'm just focusing on the internal of the primary database basically. So, and again, so this is an example scenario, right? So if I create a data guard configuration and I call this configuration test config, if I have a primary database DB1, I have a standby database DB2. On the primary database, I will set the parameters for fal-server on the primary database. I will set it to DB2 because I'm pointing to the remote database, and fal-client DB1 because I'm pointing to the local database. So fal-client is local and fal-server is the remote. And on the standby database, I'm going to set my parameter values to the fal-server is my remote database DB1, and fal-client is my local database, which is DB2, my standby database. And again, so primary database fal-server is equal to standby, fal-client is equal to primary, and standby database fal-server is a primary, and then fal-client is a standby. Okay, and I should have another diagram here. Okay, so here what I have is data guard architecture, right? The processing component. So what you have here is basically, so I'm first gonna cover the active data guard. So with active data guard, you have real-time apply. I think that's the name, the real-time query. And basically what you're doing is the data is being applied instantaneously to the standby database. So again, given that you have a strong network, databases, and on the production side you have read-write access. But on the standby side, you only have the database is read-only mode. Remember, I showed you that the setting is read-only would apply. That's the active data guard setting. And then so you can use the standby database for reporting purposes. And pretty much you can also just perform backups on these databases as well. And now in terms of the local 11G data guard architecture, so you have the production database, which is the primary database, and you have a physical. You can have a physical standby database, or you can have a logical standby database. Remember, physical standby database is an exact replica of the primary database or the production database, and the logical standby database is actually not an exact replica, and because of that, the database structure are different. They're different. And then you have to apply, you have to use SQL apply to basically to not just repetitive, but to again apply the VD data to the logical standby database. And then also in terms of the configuration that you can set, you can have these either synchronous or asynchronous VD shipping. You have the broker. So the broker is the management framework that I just configured, which you showed a while ago. So you can basically install the broker, and again, remember I told you. So once you configure the broker, I would advise you to just use that broker to do to administer your databases, and not go into the database and start changing settings, or you're going to start receiving errors on the broker saying that the database setting does not match the broker setting, and it's going to be a huge headache. Just choose, settle on one, or either the broker on using the database, on administering the database using SQL Plus, and then just use that, use that method, for your to administer your data guard environment. And in terms of the logical standby, remember I told you, so because it's the video data is applied differently, so you have a SQL apply that's going to be taking the video data and apply it to the standby database. And then you can use this standby database again. So the same thing, standby database, it has data, you can use it for reporting purposes. So pretty much these are just the two types of databases that you can configure for your standby database. Remember, but also you have snapshot standby, which is more for testing and for evaluation, maybe for development. And I have another diagram here. So I have synchronous video transfer and I have asynchronous video transfer. So let's go from left to right. So asynchronous video transfer, you have your if you see the configuration, you're risking some data loss. How so? So basically, what you're doing is you have, as data is being transferred, basically it's not ensured that there's no the standby database the primary database doesn't have to receive confirmation that the standby database, that the video data that was transferred to the standby database was successfully applied. And that's the main difference between an asynchronous video transfer and a synchronous video transfer. And remember the settings for these are, you can set this as async, and then no affirm, and then sync. I close that file. So it's async, no affirm, async, ASYNC, no affirm, NOAFFIRM, and then sync, SYNC, and then affirm, AFFIRM. Basically, so if you have a no affirm or asynchronous video transfer, then basically you would still have the same process, LNS, log writer, for online video logs, RFS, capturing the files, with the standby video log files, manage recovery process, basically applying the video data to the transferred to the standby database. And again, so this is, as you can see, this is only unidirectional, right? But if you go into the synchronous video transfer, Basically again you have the same processes as logwriter, LNS, RFS, and RMP. But here you have a communication that that's actually coming back to the primary on the primary database side. So this is a network. The line is showing the line that I have there is for the network. So you have, after the video data has been applied successfully to the standby database, what's going to happen is that there's going to be a message that's going to be generated, and it's going to be sent back to the primary database to say, okay, this data was successfully applied to the standby database. And with this configuration, there is no data loss. And so and I'm going to get into the protection mode later on in the tutorial, but basically basically, so with the standby video log files, they are really important in terms of using the maximum protection and maximum availability protection mode. This is what the standby video log file really apply. So in terms of supported database roles, you have physical, logical, you have primary, and you have standby database. So what is a database role? So database role is a specific name and set of functions that have been assigned to a database and within the Datadog configuration. So you have 4 database roles. You have in Oracle, you have the primary, you have physical standby, you have logical standby, you have snapshot standby. For physical standby databases, these are secondary databases. They ensure that database users have access to live data when primary databases are unavailable, or available or unavailable. And basically, remember I told you with this physical standby, you can have physical standby act as a takeover as a primary database if a true primary database fails, or fails, is down, or because of network issues. Power outage. And this actually serves as a reliable disaster recovery method, and it operates in video log apply mode. So log apply service automatically applies the video data to the standby database by reading DB blocks from the transferred archive log files, which is something that I mentioned previously. And all data types, char, varchar, and others, they are supported in a physical standby database. And update operations on raw data by log apply service will never return unsupported data type. So this is, and again, I'm going to explain why I have this stated here. But these are just some of the benefits, some of the advantages of using of having a physical standby database. You have all the data types that are supported, and you also have and basically, so if you have all the data types that are supported, then basically that means that you're able to, there's not gonna be any data type issues. So now, in terms of logical standby database, and again, also this is a secondary database. The users also have access to live data, but the data may not be up to date if the SQL statements produced by the LSP, which is the logical standby process, are not applied to logical standby databases. So basically, and again, so this is pretty self-explanatory. The LSP process has to apply a read data to logical standby database for you to be able to have a very consistent database, a logical standby database. And also it operates in SQL apply mode, which is different from what we have up here, which is video log apply mode. And then with transfer video, the transfer video data is not applied automatically to standby databases. So that's the difference between having a video log apply and a SQL apply. SQL apply, the data has to be applied to SQL apply, and if you have a video log apply, the video data is applied automatically to a standby database. So remember, I think it was the MRP queries video data. The video data inside of the archive log files, and basically gets the data that has to be applied to the standby database. Supported database modes for logical standby database: read only, read write, and then it does not support or data types. So you're going to see that 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 and unsupported data type just do some a little bit of research on which data types are supported for are not supported for logical standby, so you won't have to eventually be stuck in trying to in working with in having to do an update on an unsupported data type on your logical standby database. Uh, yeah, so actually, luckily you don't have to do research because I have it right here. So basically, so if you make an attempt to update the raw data containing any of these data types on your on your logical standby database, raw ID, usually find data types enclave, UID, club, default, long raw, then you're going to have an unsupported data type error that's going to occur. So yeah, so even if you transfer, so basically if you transfer these data, the data data sets that have data that have these data types that are used to to store the data to store a database to store table data, then basically you won't be able to update that table, and you won't be able to do anything with that object with a table object because these data types are not supported. And also, lastly, you have snapshot standby databases. These are secondary databases. And again, so you can only convert physical standby databases to snapshot standby databases. And then you also have, and then again, logical standby databases cannot be converted to snapshot standby databases. And the really data that you see from the primary database cannot be applied to the standby database. Remember, I showed you that it's a different setting. The flashback is setting that's going to be store point only, and basically, and all the data that you have in the snapshot standby database is going to be lost when you be converted back to physical standby database mode. And yes, so for the view data to be applied to back to the standby database, it must be converted back to physical standby database, and then you'd eventually have access to the live data that was transferred from the primary database. Yes, and all the changes that you apply to snapshot standby database are rolled back, as I've said previously. And so now let's get into attributes, attribute processing procedures. So what are attributes in this case? So these are actually properties that have been assigned to a database role. And then you have processes, and when I say processes, I'm referring to the background processes that are required to perform operations or procedures. And also these can also be tasks that are performed by the background processes. And then you have primary database processes. You have the NNS, the log write network server process. And then you have the archiver, or the ARC, ARCH, or the archiver process. It archives video logs and ensures log files are not lost or overwritten. And then you have a physical standby attributes. Basically, you have and again, so attributes I'm more referring to the advantages of having of configuring of enabling of having a physical standby database. And again, so the physical standby and primary database have the same database structure. The view data that transfers from the primary database is directly applied to the standby database. And this is being managed by the local software, more specifically the MRP process, managed recovery process. Your database is operating. Your standby database has to be operating in managed recovery mode. And also, the physical standby database can act as failover database when the primary database are going through experiencing downtime. And then physical standby processes, you have the RFS process, which is a remote file server process. The function is to receive, archive, log file from primary databases. You also have the archiver process, You also have the MRP, managed recovery process. This is uh, responsible for applying the archive video log files to standby database. So what it does is it's going to, and again, I'm starting really, I'm repeating myself over and over again. Sound really repetitive, but really, it's really important for me to emphasize this. But I'm not with the managed recovery process shit. What it does is it goes into the archive log files, transfers the archive log file, gets the video data, and applies that video data to the standby database. And then you also have the logical standby attributes. Advantages of having a logical standby database. Basically, and again, so this is again this is really not an advantage. It's not an exact match. It's not similar in that the database structure is not similar for common and logical standby databases. The Oracle log miner is used to perform the log mining. So this is a completely different process. The log miner. And then basically what it also does is it performs log mining operations that passes through the video data and generates transactions that can then be applied to the logical standby database. This is when you get into having a SQL apply as opposed to having a video log apply service. And also in the logical standby procedure and processes, you have the apply processing procedure. And basically this is what's going on internally in terms of the logical standby database. So when you're dealing with the apply processing procedure, you have a coordinator process. This is the main LSP, the logical standby process. It starts and it manages the remaining background processes that are used during logical standby updates, recoveries, and basically it just administers. Again, what a recovery is the process of applying video data to bring logical standby database to a consistent state. So you have the coordinator. Basically, it's more of it administrates over the other background processes. And then you have the apply process. It applies the SQL transactions to logical standby database. And then you have the analyzer process. It basically finds the dependencies for your SQL transactions. And again, so if you go back, so transactions that generated, are eventually generated, and basically, and this is where the dependencies come in, and this is what the analyzer does: find those dependencies, get rid of potential gaps in data. And then you also have the log mining procedure. In terms of log mining procedure, you have the reader process. It reads every line of video data in the archive video log files. You have the prepare process. It changes the video log file records to logical change records, or LCRs. So think of transactions that are being think of raw data. What it does is it's going to change those records into logical change records, or LCRs, and you can have multiple prepare processes. So after the records have been changed to LCRs, they are then stored. The LCRs are then stored in the SCR cache, and the SCR cache is actually located in the SGA, the system global area. And after that, you have the builder process. This is actually going to create the transaction from these logical change records that were generated. And then what a builder process also does is it manages the memory space for the SCR cache memory structure. And it also generates checkpoints for the SQL apply restores and purge operations that are being performed on unwanted changes to redo records. So just to put it, in plain language, basically it's gonna get rid of changes that did not have to be applied to like the standby database. So unwanted changes. Let's see. I'm going to stop here. When we come back, I'm going to go over the switchover commands. Basically switching your primary database to physical standby, from physical standby to logical standby. Thank you so much for watching. I'll see you guys next time.